I want you to grab your notebook, and I want you to think about some real-world examples that use that idea of coordinate pairs and coordinate grids. Okay, we've talked about coordinate planes before and plotting those dots on the coordinate plane. Think of some real-life examples that might use that idea. Okay, so I want you to take just a second to jot down some ideas about that. Yeah, so do I, Alyssa. Plotting coordinate pairs is really fun, and you can be really creative with it too. So take a minute to do that, and then when you're ready to begin, give me a green check. Go ahead, Jennifer. Do you have a question?
Yeah, do we have to come up with a coordinate pair, or do we have to come up with a whole story problem or something like that?
Neither one. You don't have to think of a story problem. You don't have to think of a coordinate pair. I want you to think about how that idea of a coordinate grid might be used in something real, okay, in real life. Okay, where have you seen that before, that idea? Okay, that's what I'm asking. Does that make sense, Jennifer?
Yes, it does. Thank you.
You're very welcome. Go ahead, Ava. Do you have a question?
Can I tell you the example I thought of?
I want you to hold on to it, okay? I want everybody to think of their own example, and then once we go through everything and do some practice with it and some exploring, then at the end we're going to share our examples, okay? Because I have a few to share with you as well. And so as we're getting started, you can continue to jot down your ideas and whatever in your notebook. A couple of things I wanted to just mention. First of all, good afternoon, Mrs. Horn. Mrs. Horn will be hanging out with us today and checking out my awesome, awesome students in Math 6. So welcome her this afternoon.
Hey everyone, thanks. Actually when I came in I got a lot of good afternoons and hellos. So I'm very happy to be here just checking it out, seeing what you guys are doing in Math 6. And I love coordinate pairs. I used to love doing these, and I love helping my boys now when they do it in their math class. So I'm excited.
Awesome. All right, and welcome. The other thing is the word of the week this week. I think everybody saw the post that I posted in the middle school resource room who won the prize this week. Yep, and that was posted on Friday, so if you didn't see that, go check it out. It's on the discussion board. So we're starting a new month. Here we are in March, and the word of the week this week is circumference, okay? And in the next couple of weeks, I want you to think about what all of those ideas have to do with a certain special day that's coming up, and we'll talk about that in a couple of weeks. To check in with Adam and Holly and Matthew. Are you still jotting down your ideas for coordinate grids? Absolutely fine. Green check when you're ready. Adam, are you still thinking of some ideas? We'll just get started if he's still oh, thank you, Adam, for your green check mark. Let's get started then today. Let's have a look at our to-do list. It's a big one, okay? Starting a new chapter, so we have lots to talk about. We're going to review some things that we have talked about in the past, okay? So integers, fractions, decimals, and how to show them on a vertical and horizontal number line. We're going to talk about and review again absolute value and what that means. And then we are going to plot some points on a coordinate grid and do a few activities with that and do some practice just to make sure everybody remembers how to do that. And we're going to look at perimeter of polygons. Okay, so I want you to think about what does this all have to do with coordinate graphing. Okay, so those first few things that we're going to review, I want you to think about what does that have to do with that. Okay, and then we're going to look at the parts of a coordinate grid, the axes and the quadrants, the 4 quadrants, and identify those. And then we're going to look at a relationship between the signs in an ordered pair and the quadrant in which the point is located. And then we're going to look at a relationship of the signs between a couple different activities that you're going to do, as you can see, in breakout rooms today. let's get started reviewing how to plot on that coordinate plane, okay? Let's take a look at number 1 here, for example. And what I'm going to do is just, I'll just point to the letter, and I would like a volunteer, please, if they could just give us the coordinate pair that goes along with that letter on the grid. So what is the coordinate pair for point A? Go ahead, Sophie.
I believe point A would be 4, 2.
Does everyone agree with her? Give me a smiley. Everyone agrees with you. Actually, the coordinate pair is 2, 4. Okay, remember you always read the x-axis first. Okay, so you have to move over to the right or left first and then up or down. So this coordinate pair would actually be 2, 4. Okay, does that make sense? Good thing we're refreshing our memory on this, right? Does that make sense to everyone? Give me a smiley. Excellent. Okay, Jennifer, I think you're ready to go with point B. Okay, what is the coordinate pair for point B, Jennifer?
Point B would be 4, 5.
You are correct. Excellent. Always read the X first and then the Y. Okay, how about point C? What is the coordinate pair for point C? Go ahead, Matthew.
5.
Way around. Remember, you got to go this way first. Okay, left or right first. So that would be 5 and then 1. Okay, does that make sense, Matthew? Yep, you got it. You got it. All right, excellent. Okay, let's go over to number 2 here and plot a few points, okay, just to make sure. How about point P? Do I have a volunteer that can plot point P for us? Just going to give everyone their pen so I don't have to click them on and off. All right, great. Thank you, Josie. Why don't you go ahead and plot point P for us? Alyssa, why don't you go ahead and plot point Q for us, please? And Ava, why don't you go ahead and plot point R for us, please? Everyone else, check it out. Make sure it's in the right spot, okay? Right, what do you think, the rest of you? Do we have them in the right spot? Give me a smiley if you agree with all of those. Okay, good, good. The one thing I really like is that these are labeled, okay? This one, okay, good. And I'm glad whoever had this one put that up there as well. You should always label your points too so that we know exactly which one you're plotting, right? And so they all look like they're in the right place to me. Awesome. Okay, so everybody remembers, right, how to plot a point on a coordinate plane, right? Give me a smiley. Excellent. All right. The other thing we need to review is this, okay, numbers and putting points and labeling them, okay, on a horizontal number line, okay, we need to remember how to do this too, especially negative numbers, right? Negative numbers on the number line, okay? So you can see that I have an arrow pointing down to the number line right here. And if you could just put what number that represents, pointing down to what number is that, you can write it right on top of the line there. All right, great. Thank you, volunteers. Sophie, you can go ahead and do the first one for us if you would, please. Jennifer, you can go ahead and do the second one, please. Ava, if you want to go ahead and do this one for us, please, that would be great. And Matthew, why don't you do the last one on that top number line? Everyone else, make sure they got the right numbers up there. right, what do you think, everyone else? Give me a smiley if you agree with all the numbers. Did they label them right? Yes, and I agree as well. Nice job. Yes. All right, let's go down to the bottom number line down here and do the same thing. Do I have some new volunteers that would like to jump in? Excellent. How about Alyssa? Could you do the first one for us, please? That would be great. Sophie, would you do this one for us, the middle one? That would be great. And Matthew, why don't you go ahead and do this one for us, please? What's the intervals on this number line? This one's not going by ones, right? They're not consecutive numbers, okay? So just a hint, hint, all right? Because if you notice right here, there's quite a jump from 2 to 6, right? So, what do you think that number is in between there? All right, looks like our volunteers got their numbers up there. What do you think, everyone else? Give me a smiley if you agree with them. Yes, nice job. Awesome. Okay, so let's go on to and reviewing absolute value. Okay, does everybody remember what absolute value is? Give me a smiley if you remember that. Go ahead, Sophie. Can you explain that for us?
The absolute value seems to only apply to like negative numbers, but it's like the opposite on a number line. So for example, if we have like -4, the absolute value of -4 is 4.
Excellent. And actually, absolute value can also apply to positive numbers, okay? I like what Sophie said. It seems to be that absolute value comes into play with negative numbers, and that is definitely true. But absolute value comes into play with positive numbers as well. Okay, and if you look at this, all right, and I like to think about absolute value in terms of a number line, okay? And that is simply, it is the distance from 0 on a number line, okay? That way you can think about it as positive or negative integers. It's just the distance from 0 on the number line, okay? Does that make sense to everyone? Give me a smiley. Okay, and remember these symbols, okay? These are the symbols that you use to talk about absolute value, okay? So if I put symbols around all of these, which I'm going to do, okay? So what is the absolute value of 15? Go ahead, Ava.
-15.
Actually, if you think about this now, okay, think about your answer, Ava. Can distance ever be negative? What do you think about that question, Ava? Can you ever run -15 yards? Does that make sense, Ava? Oh, that's right. Okay, and that's why I like to think about absolute value as distance, because distance can never be negative. Okay, it's always going to be positive. All right, and so the absolute value of 15 is what do you think now, Ava? Yes, you're absolutely right. It's 15. Okay, even though it's already positive in those absolute symbols, right? Absolute value symbols, it's still 15. It's positive. Absolute value is always positive. How about what is the absolute value of -56? Go ahead, Sophie.
The absolute value of -56 is 56.
You are absolutely correct. Yes, excellent. And Jennifer, what is the absolute value of negative 23?
The absolute value of negative 23 is 23.
You are correct. Excellent. Okay. And finally, what is the absolute value of negative 37? Go ahead, Sophie.
The absolute value of negative 37 is 37.
Absolutely correct. Okay, so does that make sense to everybody? That absolute value is always positive. Okay, and that's one way to think about it is it's distance. It really is. It's distance away from 0 on the number line. Make sense to everyone? Give me a smiley. Great. Okay. The last thing that we needed to review was perimeter. Okay. Perimeter. Everyone remembers what perimeter is of a polygon? Do you remember that? Give me a smiley. And so as you can see with our 4 examples up here, a couple of things that you need to remember about polygons, right? And that is the characteristics of them, okay? Because that helps you figure out perimeter. Okay, and so looking at number 9, all right, looking at number 9, because it's an equilateral triangle, what does that mean? What does that tell us? What does an equilateral triangle have? Go ahead, Sophie.
An equilateral triangle has like all sides are equal. That's what it is. All sides have to be equivalent to each other.
You're absolutely correct, and Alyssa agrees with you. She's giving you the thumbs up. That is absolutely correct. So, in other words, what is the perimeter of figure DEF, the triangle? Go ahead, Matthew.
21 inches.
Excellent. And guess what is even better is that he said inches along with it. Awesome job, Matthew. Yes, 21 inches because all of those sides are the same. Absolutely. All right, let's take a look at number 10. Now, what do we know about an isosceles triangle that can help us with this one? What do you think? Go ahead, Matthew.
2 of the sides are the same, and then the other one is a different. I think it's a little bigger.
Yes, absolutely. 2 sides are equal in length in an isosceles triangle, and that is absolutely right. Now, the other way we know that for sure is because of these little tick marks. Remember, these little tick marks right here also tell us that those sides are equal in length, right? So what is the perimeter of that triangle ABC for number 10? Go ahead, Matthew.
20 centimeters.
You are correct. Awesome job. Absolutely. Okay, let's take a look at number 11. Okay, look, it's a rhombus, WXYZ. Okay, what do we know about a rhombus? That's going to help us figure out the perimeter of this. Okay, go ahead, Sophie.
The thing about rhombus is that every single time, all the sides of the rhombus are equal to each other. So we know that here it says 4.5 feet, so we know that all the other sides are going to be 4.5 feet too.
Absolutely correct. Yes. Okay, and knowing that, then Jennifer, what is the perimeter of that rhombus?
Since you know that, you would double 9, which would be 18, and then you would double 15 too. That would be 30. So the total would be 48. 48 centimeters.
Okay, and I think you might be looking at number 12. Are you looking at number 12?
Oh, yeah, sorry.
It's okay. We got number 12 out of the way. Thank you for that, Jennifer. Yeah, you're absolutely right. That's how you would figure out that one. Okay, but how about our rhombus for number 11? What is the perimeter of that one? Go ahead, Matthew.
18 feet.
Got it. Nice job. Okay, so everybody is very comfortable with perimeter as well and taking in the characteristics of each of those polygons in order to figure it out, right? Awesome job. Okay, now we reviewed all of those things, right? Why? Why do you think we reviewed all of those things? And here's what I want you to do. I'm just going to put it on private chat so it just comes to me. Okay, why do you think we needed to review integers, graphing on a horizontal number line, absolute values, perimeter of polygons? You don't have to say it out loud. I want you just to put it into the chat. Go ahead and put it into the chat real quick. What does that have to do with graphing on a coordinate plane? What do you think? Put it in the chat box. Ideas coming in. Go ahead if you're still finishing up. Ideas. I love reading your comments. Yes, I like Elliot's comments. We're going to need all of these skills for what we're doing with coordinate graphing, aren't we? Yeah, we're going to need all of these skills. We have to be able to plot, right, points on a grid, right, and negative numbers and decimal numbers and fractions. Sometimes the numbers are in between those lines, right? So we have to be able to do that accurately, right? And there was a couple other comments in there about the fact that you can plot points and connect the dots, which makes shapes, right? And so we needed to review all of those things so that we can do our work in this chapter. You're absolutely right. All right, let's start out with all of the vocabulary that goes along with coordinate graphing, okay, because we need to understand what we're talking about, right, before we can do it. So when we're talking about coordinates, okay, the coordinate pairs, I think you're all pretty comfortable with that already. The coordinates are an ordered pair of numbers that identify a point on a coordinate plane, right? It's the X and the Y coordinates, and that I have a little bit further down on the list here. The X coordinate in the ordered pair is the value that is always written first. Okay, that's always the first number in the pair. Whereas the Y coordinate in an ordered pair, that's the value that is always written second, as you can see in this example. Okay, so those are coordinates. Those are coordinate pairs, right? And the coordinate plane is a two-dimensional system in which the coordinates of a point are its distances from two intersecting, usually perpendicular, straight lines called axes. Okay, that's what a coordinate plane is. And think about that, two-dimensional. And we're going to look at some examples of real-life examples, and you'll see that they are two-dimensional as well. Okay, the x-axis is the horizontal axis. Okay, that's the one that goes this way, right? And so that is what we tried to point out when we were practicing, is that you have to read that first number and read it left to right on the horizontal axis first. Okay, once you got that, then you go to the y-axis. That is the vertical axis, and that's where you take the second number and you go either up or down. Okay, is everybody pretty familiar with all of these things then? Give me a smiley. Great, okay, and I thought you might be because we've talked about this before, okay? Now one thing you might not have seen before is quadrants. Give me a smiley if you've seen this word before. Do you know what quadrants are on a coordinate plane? Okay, this you don't see too often, but quadrants are actually the four sections of a coordinate grid that are separated by the axes. Okay, so we're going to take a look at that. The quadrants look like this. Okay, as you know, the x-axis and the y-axis, right? The first quadrant is right here, and it just follows around in a circle. Okay, so quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, now notice the points that are in each of these quadrants. Okay, notice the points and what that coordinate pair would look like. So I'm just going to leave this up for a second so you can kind of study it and notice all the different, what the coordinate pairs would look like in each quadrant. Go ahead, Sophie.
Based on the shape, or like where all those circles are, I think it looks like a rectangle.
Yes, I think you're right. If I was to go ahead and connect the dots, that's the fun thing about coordinate graphing, right? You can plot the points and then you can connect the dots. Makes it fun, and you can make different shapes and different things, right? So Sophie is right. If I were to connect those dots, it would be a rectangle, and there it is. Okay, now notice the numbers. Okay, notice the numbers in each of the quadrants. And the next screen I go to, I'm going to ask you. Okay, if I was to ask you to describe the points that would be in quadrant 1, okay, what would you tell me? What would the coordinate pairs look like that would appear in quadrant 1? Go ahead, Josie.
The coordinates in quadrant 1 would be all positive numbers and would be on the top right of the coordinate plane.
Excellent. Yes, you're absolutely right. That's a great description. They would all be positive numbers, right? The x and the y coordinate would both be positive numbers. Okay, how would you describe the coordinate pairs in quadrant 2? What would you say about that? Go ahead, Sophie.
In quadrant 2, you'll see on the x-axis, you'll see negative numbers, and on the y-axis, you'll see positive numbers. And you can find it on like the top left of this chart.
Excellent. Yes, you're absolutely right. Okay, so the x-coordinate is going to be negative, and the y-coordinate is always going to be positive. Excellent. How about quadrant 3? How would you describe the coordinate pairs that would appear in quadrant 3? Go ahead, Sophie.
Okay, this is kind of different. In quadrant 3, this time the x-axis is located on the top, and so these are all negative. X-axis is negative, and the y-axis is negative. Yeah, and it's also located at the bottom left.
Yes, she's absolutely right. Okay, so the x-coordinate would be negative and the y-coordinate would also be negative. Excellent. Okay, how about quadrant 4? Can you describe the coordinate pairs that would appear in quadrant 4? Go ahead, Sophie.
In quadrant 4, which is located on the bottom right, the y-axis is negative this time, and the x-axis is positive.
Yes, absolutely. Yes. Okay, so the x-axis, the x number, the x-coordinate is going to be positive, and the y-coordinate is going to be negative, and it's going to appear over here. Excellent. Okay, so those are the quadrants, quadrant 1, 2, 3, and 4. They just kind of go around in a circle starting right here. That makes sense to everyone? Give me a smiley. Right, great, excellent. Okay, let's move on and do something with this, okay, this one. What I want us to do is I want you to put your initials, and I want each of you that volunteers to plot this coordinate pair on the grid. All right, great. Sophie, go ahead. You can put your initials in the blank right here. Ava, go ahead. You can do the second one. Put your initials in right here. Josie, go ahead. You can do this one. Alyssa, 0 and 3. Matthew, 1 and 4. Jennifer, 2 and 4. Do I have one more volunteer? All right, I'll do the last one. Okay, let's go ahead and get all of our points plotted on our grid and see what we end up with. Okay, I think, let's see, I think it's Matthew right here. I think you might need some help with yours. Remember, you're going to read the x coordinate first, Matthew. And so that means you're going to move over 1, okay, over to the right 1. And then it's a positive 4. So that means from there, you don't put your point there yet. Remember, you just move over, okay? Don't put your point yet. But then you move up 4, okay? So Matthew, actually your point is going to go right here. Yeah, there you go. Okay, so I think we want to take this one off right there, right? Go. Okay, I think we got them all now. Awesome job. Now I need a volunteer to connect the dots for us. All right, Alyssa, can you go ahead and connect the dots for us? Awesome. There it is. Yep, and that's what's on this next screen too. Seagull, right? It's a seagull in flight. Nice job. Okay, let's do it again. Okay, let's try it again and see what we come up with this time. Volunteers again. You can go ahead and put your initials right next to the coordinate pair. Go ahead, Sophie, you can do the first one. Matthew, go ahead, you can do the second one. Ava, go ahead, you can do the third one. Alyssa, go ahead, you can do the fourth one. Any more volunteers? Great. Josie, go ahead, you can do the next one. Jennifer, go ahead, you can do this one, 1 and -1. Adam, Elliot, Holly, do you guys want to volunteer? Jump in. Need 2 more. Great, thank you, Elliot. Why don't you go ahead and do this one for us, Elliot? Do the last one for us so we can complete it. I think somebody's got it up there for us already. Awesome. Okay, good. Volunteer to connect the dots for us on this one. Go ahead and do this one for us, Matthew. kind of tricky on this one. Maybe you're not sure what I'm looking for, but start up here. Yeah, you got it. There you go. Awesome. There it is. That's what it should be. So that means everybody plotted their point correctly. Nice job. All right, here is what we're going, yeah, a house maybe, or an arrow. It could be, right? Either way. Here's what we're going to do. I'm going to put you into a breakout room, okay? And what I have for you in there is 2 slides, okay? 2 slides that has 2 sets of coordinate pairs, okay? There's 2 slides in there, 2 sets of coordinate pairs for you to do, okay? And I want you to plot the points. It looks like this one right here. There's 2 separate plots here, 4 in each section. So plot A, B, C, and D, connect the dots. Plot E, F, G, and H, connect the dots. Okay, and I want you to notice the relationship, okay? Not only with the figures, the 2 figures that you're doing, but also the numbers in the coordinate pairs, okay? So there's 2 slides in there. They both look like this, but they have different numbers, okay? And I want you to notice what is going to happen with them, okay? And I'll give you a hint. And before you even start plotting that second figure, I want you to predict what you think might happen, okay? What do you think is going to happen with that second one? And a little hint, think about our geometry jargon words that we've been talking about in the last month. Reflection, rotation, translations, symmetry perhaps, okay? Keep those words in mind as you plot them, okay? So does everybody know what to do? And I'll set the timer for probably shouldn't take you like more than 8 minutes, and then we'll come back and talk about what you found out, okay? Does everybody know what to do? Give me a smiley. Excellent. Okay, so as soon as you get there, get started, and then we'll come back when the timer goes off. All right, we should all be back in the main room. I know that some of you didn't quite get that second one finished yet, but what did you notice? What did you notice when you did each of the activities on each of the slides? What did you notice about the figures? Go ahead, Sophie.
I noticed that like in the first slide, I noticed that it showed like the same shape, except it was like located differently. And I think I kind of noticed the same thing in the second slide. The shape was like rotated in a different way.
Okay, excellent. All right, nice observation. Go ahead, Alyssa. What did you notice?
I noticed on the second slide that the shape was a reflection of the other one, and well, we didn't quite finish the first slide, so, but I was going to go along with what Sophie said. I agree with what she said about the first.
Excellent. Okay, great. Thank you. Jennifer, what did you notice?
I noticed that the one on the second one was like the same thing as the one on the first slide. Sorry, I can't think of it right away. So it's sort of like symmetry. I think that's the word I'm looking for. I'm not sure.
Ah, excellent observations. Yes. Okay, so the first slide, these are the coordinate pairs that you did on the first slide. And notice the numbers, okay? The only thing that changed between these coordinate pairs is that we made the y coordinate negative. Okay, so you should have ended up with a figure up here, quadrilateral up here, and if you noticed, it was reflected over the x-axis, okay? And the only thing we changed was the sign of the y coordinate, okay? How many of you noticed that? Give me a smiley. Great, okay, excellent. And on the second slide, okay, notice what was different on the coordinate pairs on this one. All we did was took the opposite, okay, of the x-coordinate on this one. That's what it is. It's the opposite of the x-coordinate here for each of them. That's the only thing that we changed. And that one ended up to be actually kind of an overlapping reflection. Okay, how many of you found that it overlapped and it looked like it was reflected over the y-axis? How many of you noticed that? Give me a smiley. Okay, great job. All right, so what I want you to do, there is some grid paper that is posted in the module for this unit, and I want you to grab some of that grid paper, okay? Print off as many copies as you would like, okay? And try this, okay? Plot a figure, write down the coordinate pairs, and see if you can reflect it by changing the numbers around a little bit, okay? See what kind of a reflection you get. Go ahead, Sophie.
Do you think we'll also be able to review this in our homework?
You definitely will. Okay, and the other thing I'm challenging you to do is like the seagulls in flight, okay, one that we did, and the arrow pointing up, or the house, okay, see if you can design one. Write down your coordinate pairs, okay, and plot it onto the graph. And if you want to bring it to class on Wednesday, we'd love to see it, okay, so give that a try as well, okay. Now, let's go back and talk about those examples of coordinate grids in real life. Does anyone want to share their ideas? Sophie?
Okay, I wrote mine down. So this is what I wrote. Marco reads a number of pages from his book. Marco's sister, Oliver, reads 4 more pages than Marco. The siblings read their books on a daily schedule. First Marco, then Oliver.
Okay, so she's kind of thinking of linear equations, isn't she? Awesome job, Sophie. She's kind of tying it into where we left off in the last unit. That's awesome. Thank you, Sophie, for sharing that with us. Go ahead, Alyssa.
I would think mine's kind of, it's also kind of like Sophie's again, kind of. So, Jimmy lives 1 mile from New York. He also lives, sorry, I can't rethink mine, I messed up.
It's okay. It's really hard to understand you, hon, anyway, because your microphone is really choppy. I'm sorry. But you know what? I was thinking of just some real-life examples that you probably don't even realize that this whole idea of coordinate grids is in use. Let me give you some. Go ahead, Ava. You want to share yours before I share mine?
Yeah, my example of like how we use the grid is pinpointing a location on the Earth. We use a grid for that.
Yes, absolutely, Ava. Awesome example. That's the example I was going to share with you. And I'm just going to show you real quick. Google Maps, that's what it is. It's all based on a grid system. That's exactly what it is. That whole idea of a GPS and Google Maps, that is all based on a grid system. Okay, and I'm just waiting for my example to come up here so that I can show it to you. But I just punched in this website that I found, Google Maps, GPS coordinates. It's all based on that. The latitude and the longitude, that's a coordinate grid system, you guys. There it is. Okay, and that's been around for a long time. And I just punched in the school address, and here I got, 43.28 degrees north latitude and 87.56 degrees 87 degrees west longitude for the school address. It's all based on the grid system, okay? And that's exactly what it is. A couple other quick examples before you go. How about a good game of Battleship? That's a grid system, isn't it? Yeah, it's there. That's all a grid system too. It's in a game, right? Here's another example. Did you ever look in the phone book and look up a street address? Okay, and you have to use the ABC on the side here and match it up with the 1, 2, 3, 4, 5 here to find an exact location. Grid system, okay? Does that make sense to everyone? Give me a smiley. Go ahead, Sophie.
I noticed based on like the layout, but I know it's like chess kind of uses a grid system, except not when you move those, you know, those like statues, or that's what I call them. But it's like format seems very much like a grid system in my opinion.
I would agree with you. Yes, you're absolutely right, right? Those little squares are all, it's all designed like a grid. Absolutely. Great example. Okay, so here's what the homework is, and here's the fun part. I really want you to go give this a try. There is a practice website for you too to go to, so that you can go, you know, have some fun plotting some ordered pairs on a fun website as well. But grab some graph paper and see if you can design something really cool to bring into class on Wednesday. Okay, does anyone have any questions today?